Welcome back to the deep dive. Today we're taking a deep dive into the world of deep learning.
It's exciting stuff.
Yeah, we've got this fascinating textbook chapter
Okay.
all about it, and I'm really excited to dig into this with you.
Me too.
One of the things that jumped out at me just kind of skimming through the material
Yeah.
is how many different names this field has had over the years.
Oh, yeah.
Like cybernetics and connectionism,
Mm-hmm.
artificial neural networks. It's almost like it's had like multiple identities over time.
It really has. And, each of those names kind of reflects a different emphasis.
Okay.
A slightly different focus.
Yeah.
Maybe a shift in what was popular at the time.
Yeah.
But what's really fascinating is if you look at the underlying principles,
Yeah.
the core ideas have actually remained remarkably consistent. It's more that the scale
Okay.
and the applications that have really transformed things.
The book actually has this really cool chart in it
Oh, right?
that shows the popularity of these terms over time. And it's based on how often they pop up in publications. And you can see these distinct waves
Right.
of research activity.
Exactly.
Yeah.
Yeah. And one of the things that really drives these waves
Okay.
is data.
Data. Okay.
Deep learning thrives on data.
Oh, interesting.
And the more data we have,
Yeah.
the better these models can perform.
So you're saying like in the early days when they didn't have as much data,
Right.
that was kind of a limiting factor.
Yeah, it really was a bottleneck.
Yeah.
If we think back to those early days of research,
Yeah.
the data sets were minuscule compared to what we have today.
So the big data era was a total game changer then.
Absolutely. It was like this perfect storm.
Yeah.
This explosion of digital information
Yeah.
gave these algorithms the fuel they needed
Oh,
to really
whoa.
take off.
I see.
The book gives a great example of ImageNet.
Okay.
This data set with millions of images
Yeah.
that's been so crucial for computer vision.
Oh, yeah. I've heard of ImageNet.
Imagine trying to teach a computer to recognize objects using just a handful of blurry photos.
Yeah.
Progress would have been painfully slow.
It makes sense that you need a lot of data.
Definitely.
This leads to something else I was thinking about when I was reading through the chapter, which
Yeah.
is the idea of the brain as inspiration for deep learning,
Right.
but not necessarily a blueprint.
Yeah.
It's kind of a subtle distinction, but I think it's important.
Yeah, it is. It's a really important point. Those early pioneers in the field,
Mm-hmm.
they were very much trying to replicate the brain's functionality.
Oh, wow. So like build an artificial brain.
In a way, you think about the McCulloch-Pitts neuron from 1943.
Okay.
One of the very first attempts to actually model a brain cell or the perceptron in the 1950s.
Okay.
Groundbreaking stuff, but also very simplified models.
So are we still trying to build an artificial brain in a computer or?
Not really, no.
Okay.
I mean, the brain still offers valuable insights,
Okay.
but the focus now is more on extracting general principles
Okay.
from it rather than trying to copy it exactly.
Okay.
I mean, honestly, we just don't understand the brain well enough to create a true replica.
Right.
And it may not even be the most efficient way
Oh, interesting.
to build intelligent systems.
So if data is the fuel, what's the engine driving the progress then?
Well, a big part of it is model size.
Model size.
Yeah, deep learning models have been growing exponentially,
Oh, wow.
driven by increased computing power and, all of that data that we talked about.
So bigger is better in this case.
In many cases, yes, larger models mean greater complexity and the ability to tackle more challenging tasks
Okay.
with higher accuracy. It's pretty amazing to think about.
Yeah?
We've gone from models with a handful of neurons to models with billions of them.
Oh, wow.
It's wild.
That's a huge increase.
The book has a really interesting comparison, actually.
Okay.
It tries to visualize the size of neural networks
Mm-hmm.
compared to the number of neurons in different animals.
Oh, wow.
You see that little leech with its tiny nervous system. Then you've got a frog, and then finally a human.
Yeah.
And these deep learning models, they're right up there,
Oh, wow.
rapidly approaching the scale of the human brain.
It's kind of a crazy thought.
It is. It's pretty mind-blowing.
Yeah. So we've come a long way,
Yeah.
and these models are getting huge.
Definitely.
What about the impact of all this progress, though?
Right.
Like, how is this actually changing the world around us?
That's where things get really exciting.
Okay, let's hear it.
So let's start with something like object recognition.
Okay.
The book shows how error rates in image classification
Yeah.
have plummeted thanks to deep learning.
Wow.
Remember ImageNet?
Yeah.
Deep learning just crushed it.
Okay.
And those error rates have just continued to drop year after year.
So we've gone from just recognizing a single object in a photo.
Right.
What?
to much more complex tasks,
Right.
like imagine transcribing an entire sequence of characters
From an image. Wow.
from an image.
Right.
Yeah. Turning a photo of a handwritten note
That's incredible.
into text.
Wow.
It's incredible what's now possible in terms of accessibility and digitizing historical documents,
Yeah.
all thanks to deep learning.
I'm thinking about those ChatGPT CHAs we used to have to solve online,
Oh, yeah.
proving we weren't robots.
Right.
I bet deep learning has made a lot of those obsolete.
You're absolutely right. And it's not just images,
Hmm. Okay.
Well, think about speech recognition. Those early speech-to-text systems,
Yeah, those were terrible.
painful,
That's so frustrating.
right? Notoriously inaccurate and frustrating to use.
Yeah.
Deep learning came along, slashed error rates,
Wow.
and paved the way for, those voice assistants we all rely on now.
It seems like deep learning is everywhere now.
It really is.
Yeah.
The book also talks about machine translation,
Yeah.
robotics,
Mhm.
reinforcement learning in games.
Yeah.
It feels like it's everywhere.
So we've got these core principles that are
Stop.
driving all of these different applications.
Exactly.
But how accessible is this stuff?
That's a good question.
Is this something that only a select few experts can really work with?
Well, that was certainly the perception for a while.
Yeah.
But one of the most important developments
Okay.
has been the creation of software libraries,
Okay.
like Theano TensorFlow and PyTorch.
Okay.
These tools have made it significantly easier.
So it's not just about the algorithms,
Right.
but it's about the tools that make them usable.
It's a great way to put it.
Okay.
It's like giving a powerful set of instruments to a musician.
Yeah.
Without them, the music wouldn't exist.
It's a good analogy.
And
Yeah.
that's what these software libraries are doing. They're providing the infrastructure
Yeah.
that's powering this whole deep learning revolution.
I see.
They've democratized access to this technology,
Okay.
allowing more people to contribute to its advancement
That's awesome.
and to find new applications for it.
And this collaborative effort
Yeah,
is really driving all this progress.
absolutely. You've got researchers building on each other's work, sharing code and data sets,
Yeah.
constantly pushing the boundaries.
That's so cool.
It really speaks to the power of open science.
Absolutely. And this collaborative spirit extends beyond computer science.
Oh, totally.
The book talks about deep learning being used
Yeah.
to predict molecular interactions for drug discovery,
Right.
to search for subatomic particles in physics experiments,
Mm-hmm.
and even to map the human brain.
It's incredible.
It seems like deep learning is becoming a universal tool
Yeah,
for scientific exploration.
you could say that.
The potential applications are just mind-boggling.
They really are. And it's an exciting time to be involved in all of this.
Yeah,
We're only just beginning to scratch the surface of what's possible.
I believe it.
But as we delve deeper, some fascinating questions emerge that we need to start addressing.
Interesting.
Like how do we make sure all of this is being used responsibly?
Yeah, that's a great point.
It's not all just fun and games, right? Like, for instance, as these models get more and more complex, how do we ensure they remain interpretable?
Oh, that's interesting.
How do we actually understand what's going on inside these systems?
Especially as they're making more and more decisions.
Exactly. And especially decisions that have real-world consequences.
You're right. Like, we can't just blindly trust them.
It's not enough to just know that they work.
Yeah.
We need to understand why they work.
So interpretability is a big challenge.
It's a huge challenge, and it's something that researchers are actively working on.
Okay, so what other issues are folks grappling with in the field?
Another big one is data bias.
Data bias.
Yeah. These models learn from the data they're trained on.
Right.
So if that data reflects existing societal biases, well,
Those biases are going to show up in the model.
exactly, they can get baked into the model,
Yeah.
and then that can lead to unfair or discriminatory outcomes.
And that's something we definitely want to avoid.
Absolutely. So it's really important to think critically about the data that we're using.
Yeah, I'm getting the sense that deep learning isn't this perfect solution.
It's not a magic bullet.
Mm-hmm.
No, it has incredible potential.
Yeah.
But we need to be mindful of these pitfalls as we're developing and deploying these systems.
So it's about striking a balance.
Exactly, a balance between progress and responsibility.
That's a good way to put it.
It's not just about building bigger and better models. It's about making sure they're used ethically
Right.
and for the benefit of everyone.
That makes a lot of sense. I think our listener will really appreciate this
I hope so.
kind of nuanced perspective on things
Yeah.
because it's easy to get caught up in all the hype
It is.
and excitement.
And there is a lot to be excited about, but there are these real challenges too.
Definitely. Well, the book delves into the history of this field a bit
Yeah.
and outlines these three distinct waves of neural network research:
Uh-huh.
cybernetics connectionism, and then the current deep learning era.
That's right.
And it's interesting how each wave kind of built upon the foundations of the previous one.
It's really cool to see that progression,
Yeah.
addressing limitations, opening up new possibilities.
What struck me about the deep learning wave
Okay.
is that the learning algorithms themselves
Yeah.
aren't that different from what folks were using back in the 80s.
You're right. The core ideas are very similar. It's just
Okay.
the scale of things has changed so
It's
dramatically.
all about the scale.
It really is. It's about larger models, vaster data sets,
Right.
exponentially greater computing power.
So sometimes breakthroughs aren't about inventing something totally new.
Yeah.
It's about taking existing ideas
Exactly.
and giving them the resources they need.
It's like deep learning was waiting for that perfect storm
Yeah.
of data computing power and algorithmic refinement.
To reach its full potential.
Exactly.
It makes you wonder what other groundbreaking innovations might be out there,
It really does.
just waiting for the right conditions to emerge.
That's a great question. Like, what if we could build models with trillions of neurons?
Or what if we had data sets that encompass like all of human knowledge?
It's mind-boggling to think about.
It really is. Okay, so the book also has some really cool examples
Oh, yeah.
of how deep learning has already pushed the boundaries
Right.
of what we thought was possible. Like, there's this one story about how scientists were able to rewire the brains of ferrets
Oh, wow.
so that they could see using the auditory processing region of their brain.
I remember reading about that. That's incredible.
It's mind-blowing. It really challenges our assumptions about
It really does.
like how the brain is structured and how specialized different regions are.
Yeah.
It seems like there's a lot more flexibility than we initially thought.
And it raises the question of whether maybe a single algorithm could potentially solve a wide range of tasks.
Just like the brain does.
Exactly.
Yeah.
Maybe there's this kind of underlying universality to intelligence.
Oh, that's a fascinating thought.
Yeah, maybe there's a set of core principles that can be applied across different domains.
Whether it's vision or language.
Right? Or even something we haven't even thought of yet.
Are we on the cusp of like a general purpose AI then?
That's the million-dollar question, isn't it? And it's
Yeah.
one that's being hotly debated in the field.
What does the book have to say about it?
Well, it mentions some promising avenues of research,
Okay.
like neural Turing machines.
Neural Turing machines.
Yeah, these are systems that are designed to learn how to read and write from memory.
So essentially they can program themselves.
That's the idea. Imagine the possibilities if we could create systems that could continuously learn and adapt.
Wow, without needing explicit instructions for every single task.
Exactly. They could just figure things out on their own.
That's both exhilarating and a little bit terrifying.
It is a pretty profound concept to grapple with.
Yeah.
And as we develop these increasingly powerful systems,
Right.
we need to be thinking about the ethical implications as well,
For sure.
making sure that these tools are used responsibly
Yeah.
for the betterment of humanity.
It's a lot of responsibility.
It is, but it's also an incredible opportunity.
Okay, so we've talked about interpretability,
Yeah.
data bias,
Right.
neural Turing machines.
Uh-huh.
What other areas is deep learning making waves in?
Well, another big one is reinforcement learning.
Reinforcement learning.
This is where systems learn through trial and error.
Oh, interesting. Like how we do.
Exactly, by interacting with their environment and receiving feedback.
I see.
Rewards or penalties.
So we're giving them a sense of curiosity.
In a way, yeah, a drive to explore and learn.
And this has led to some pretty impressive results.
It has, deep learning systems, mastering complex video games,
Right.
robots learning to navigate challenging real-world environments.
Yeah, it's amazing what they can do now.
It's a really powerful approach because it allows these systems to learn in a more organic way.
Yeah.
Instead of relying on pre-programmed rules, they can kind of figure things out for themselves.
So it's more adaptable.
Much more adaptable and versatile.
So in a way, deep learning has come full circle. From those early brain-inspired models
Yeah.
to these sophisticated systems we have today,
Right.
which are now being used to create systems that learn more like we do.
And what's really driven this whole journey is this incredible spirit of collaboration.
Yeah, we talked about that earlier.
Researchers from all these different disciplines
Yeah.
coming together to push the boundaries of knowledge.
It really highlights the importance of that interdisciplinary approach.
Absolutely.
Yeah.
It's not just computer science, it's neuroscience, psychology, linguistics.
It's everything.
It really is. Deep learning is this melting pot of ideas and approaches.
And that's what makes it so dynamic.
It's constantly evolving.
Yeah.
It's not just a technology. It's a reflection of this ongoing quest
Yeah.
to understand intelligence, both natural and artificial.
You know, it's amazing to think how far deep learning's come
It really is.
in such a short amount of time.
Yeah.
I mean, we've gone from those early models struggling to recognize basic shapes to these systems that can translate languages and write different kinds of creative text formats and even compose music.
It's mind-blowing when you think about it.
Yeah.
Really speaks to human ingenuity
Yeah.
and, our desire to just learn and push the boundaries.
Yeah, and the book highlights some trends that I think are really interesting.
Yeah.
We've already talked about the growth in model size, but
Right.
the accuracy and the complexity of the tasks that these models can handle now,
Oh, yeah.
it's incredible.
It's astounding.
Mm.
Even just a few years ago,
Mm-hmm.
we would have been amazed by a model that could accurately identify dog breeds.
Yeah.
Yeah?
Yeah, that was a big deal.
And now we have models that can generate photorealistic images of people and objects that never even existed,
Wow.
compose original music in all these different styles, and even write,
It's great.
different kinds of creative content.
Yeah, and the progress in reinforcement learning has been just as remarkable.
Absolutely.
The ability for machines to learn through trial and error
Right.
without explicit programming.
It's opened up so many possibilities.
Yeah, self-driving cars, game playing, AI robots that can learn to do all sorts of tasks
It really is a revolution.
in the real world.
Yeah. And it's not just about, creating machines that can do these specific things.
Right.
It's about understanding the fundamental principles of learning and intelligence
Yeah.
by studying how these deep learning systems work.
Mm-hmm.
They acquire knowledge and solve problems.
Yeah.
We're actually gaining insights into our own brains. Might work.
It's almost like we're holding up a mirror to our own minds
Yeah.
and trying to understand ourselves better.
Through the lens of AI.
Through the lens of AI,
It's
exactly.
a free, humbling thought.
It really is. And you mentioned earlier the concept of neural Turing machines.
Oh, yeah.
Which I thought was super fascinating.
It's a wild idea,
Yeah, these systems that can learn how to read and write from memory.
Right. Essentially learning to program themselves.
It's kind of scary,
It is a little bit.
but also really exciting.
Yeah. It's definitely both. It's a glimpse into this future where AI might be able to solve problems that we haven't even thought of yet.
And it raises all sorts of questions about,
Oh, yeah.
the future of work, the role of humans in this world. It's becoming more and more AI driven.
And what intelligence even really is.
Yeah, what does it mean to be intelligent?
That's a big one.
It is. And as we keep making these advances with deep learning,
Yeah.
we need to be doing it responsibly, right?
Absolutely.
Yeah.
We can't just focus on the technology itself.
Mm-hmm.
We need to think about the consequences
Yeah.
and how it's going to impact society.
We need to make sure that AI is serving humanity
Right.
and helping us create a better world.
For everyone, that's the goal.
Exactly. And that future.
Yeah.
It's being shaped right now.
It really is. In research labs and universities all over the world,
Yeah.
the pace of innovation in this field is incredible.
It's really moving fast.
It's only going to get faster.
So it's an exciting time to be paying attention.
It is. If you're interested in this stuff,
Yeah.
stay curious. Keep learning.
Yeah.
Get ready for a wild ride.
I think that's a great note to end on.
Yeah.
We've covered so much today.
We have.
From the history of deep learning to the
Oh.
incredible things it's doing now
Yeah.
and all the potential it has to change the future.
It's been a really fascinating conversation.
It has.
And I hope our listener has, come away with
Yeah.
a new appreciation for this field.
For the power of deep learning.
Absolutely. For the possibilities and for,
Yeah.
the really profound implications of it all.
So keep exploring, keep asking questions.
Yeah.
And keep learning, because the world of deep learning,
Right.
it's vast. It's always changing and it's full of surprises.
You never know what's going to happen next.
Until next time, happy diving.
See you, everyone.